Hi Math 30s. We're continuing with our study of exponential and logarithmic functions, moving on to lesson 2 in our workbook, and lesson 2 corresponds to page 165. So what this lesson is going to be on is solving exponential equations with a common base. And we learned in lesson 1 how we are going to make common bases. Okay, so here is sort of a review of how we're going to solve exponential functions with a common base. So what I have highlighted here, I want you to highlight. I want you to star these 2 points, underline what I have underlined, and then drop the base. Okay. All right, so let's look at this example here. So if I said solve the following example, so 3x is equal to 81. We are solving for what x is, and x is an exponent, right? How do we solve an exponent? We've never done that before in math. So the first step is to write each side of the equation in the same base. So what you do is we have a base 3 here. That means this 81 needs to be rewritten with base 3. So 3 to the power of x is equal to 3 to the power of what number will give you 81? You could guess and check on your calculator, or you could type in 3 to the power of x on your calculator, and we could look at our table. So on your calculators in Y1, if you type in 3 to the power of x, and then you look at your table, 3 to the power of 1 is 3, 3 squared is 9, 3 cubed is 27, 3 to the power of 4 is 81. So converting 81 to base 3 would be 3 to the power of 4. So that was sort of step 1, right? Each side of the equation in the same base. Then we sort of go to this step for this question, equate the exponents on each side of the equation. So what we could do in math is if we are dealing with an exponential equation and we have each side of our equation with the same base, we could do what's called drop the base. You're going to drop the base and you're going to equate the exponents. So because I have the same base, I can now drop the base, and I've got x is equal to 4. How you would check that is you would go back up to your original equation, and we're going to put a 4 here. And we're going to check on our calculator, is 3 to the power of 4, which we already know, is at 81. So on my calculator, 3 to the power of 4 is in fact 81. So let's go through the 3 class examples in this book. Okay, solve the following exponential equations. In A, we already have the same base, so step 1 is done, right? If I go back up here, write each side of the equation the same base, we are good. So now what I could do is I could drop the base and equate the exponents. So 2x plus 3 is equal to 7, and we're going to solve for x. Subtract 3 from both sides. 2x is equal to 4, divide by 2, and we get x is equal to 2. How we could verify that we're correct is I'm going to put a 2 here. So 2 times 2, because it's 2x, so 2 times 2 is 4 plus 3 is 7. 5 to the power of 7 is going to equal 5 to the power of 7. Left-hand side equals right-hand side. Okay. We would have to do step 1 for this question. I've got a base of 7 here. That means I need to convert 343 to base 7. So 7x minus 2 is equal to 7 to what power is going to give you 343? So take out your calculators and go to y and type in 7 to the power of x. Look at your table, and 7 to the power of 3 is 343. So I've done step 1, which is writing both sides of my equation with the same base. You can then go on to step 2 and drop your bases. Equate your exponents. X minus 2 is equal to 3. Get rid of the negative 2 by adding 2 to both sides, and you're going to get x is equal to 5. To double check, 5 minus 2 is 3. 7 to the power of 3, if you type that in, you will get 343. We need the same base. Okay. So I've got base 3 here and base 81. What you want to always try to do is if you have a larger number, see if you could rewrite this 81 by base 3. So 3 to the power of 5x minus 1 is equal to, I only want the 81 in base 3, and outside of the bracket is a 3x, right? I just want to figure out 3 to what power will give me 81. You could double check on your calculator, but it is 3 to the power of 4. Okay, in this example, before we do dropping the base, we're going to do this intermediate step. So once we have the same bases, it says, if necessary, use exponent laws so that each side of the equation contains only one base. So we do have the same base, but we want to do power to a power here. So 3 to the power of 5x minus 1 is equal to 3 to the power of 4 times 3 is 12x. We could now drop our bases and equate the exponents. 5x minus 1 is equal to 12x. We want to get the x's together. So I'm going to subtract 5. I'm going to join my like terms. So x's would be considered a like term. And I'm going to have negative 1 is equal to 7x. I need to isolate x by getting rid of that 7. And I'm going to have x is equal to negative 1/7. Okay, let's do this one. 3 to the power of x, so my base, they're telling me from here I'm getting a base 3, is equal to 27 times the square root of x. So the first thing I want to do is I'm going to rewrite this as a rational exponent. So take it out of the radical sign, and you're basically doing your reverse flower power. So we know that that's root 2 and a power of 1. So this would be roots go on the bottom and powers go on top. So rewriting this entire thing, it would be 3x is equal to 27 times 3 to the power of 1/3. Base 3, I need to rewrite 27 as a base 3. 3 to the power of x is equal to 3 to what power will give you 27? 3 to the power of 3 will give you 27 times 3 to the power of 1/2. Or sorry, why do I have a third here? I'll fix that. That should be 1/2. Okay, so now what I could do is I could do my exponent law here. This would be product law. Bases are the same, they're being multiplied. So we're going to add those exponents. 3 to the power of x is equal to 3 to the power of. So without using our calculator, this is 3 over 1 plus 1/2. Let's get the same denominator. So this is a denominator of 2. Let's multiply this by 2 and this by 2. That would be 6 plus 1, 7 over 2. Okay, so it's all I did was I know that this was product law again, and I added the exponents. 3 plus 1/2 is going to be 7 over 2. You should not need your calculator to do this. X is equal to 7 over 2. That's class example number 1. Let's do class example number 2. Okay, a bacterium triples every 6 days. So we're going to start with 1 bacteria, then we're going to have 3 bacteria, and it's just going to keep tripling. The number of bacteria, N, present after X days is given by this formula here. So N is the number of bacteria, and X is the number of days. So let's write our formula down. N is equal to 3 to the power of X over 6. After how many days are there 243 bacteria? So you have to be able to figure out, is this N or is this X? N is the number of bacteria. So they want to know when N is 243, what's X? How many days? So let's substitute out N and put in 243. is equal to 3 to the power of x over 6. Okay, from here, we need common bases. I've got a base 3 over here, so I need this to be base 3. So on the right-hand side, I have 3 to the power of x over 6, and you have to figure out 3 to what power will give you 243. So you could look at your calculator on your table, or you could guess and check. It's 3 to the power of 5. We now have the same bases, so we could drop the bases and we could equate our exponents. So 5 is equal to x over 6. We need to isolate x, multiply this side by 6 and this side by 6. X is now isolated, and x is equal to 6 times 5, which is 30, and that is 30 days. Because this is technically a word problem, you would write a sentence if this was ever on a quiz or an exam. So you would say after 30 days, there would be 243 bacteria. How we could check this, it's always good to do a check whenever you can. We got that x is 30 days. So what we're going to check is that we were correct. X is 30. So n is equal to 3, and I'm going to put 30 divided by 6. N is equal to, and let's punch this in onto our calculator, 3 to the power of 30 divided by 6. 243. You could have conversely 3 to the 30 divided by 6, sorry, is 5. So 3 to the power of 5 is 243. So N is equal to 243 bacteria, and that's what we got up there. This is the last question in lesson number 3, but it's the most complex question. Okay, solve the following exponential equation by converting each side to a common base. So what happens is sometimes you just have to be intuitive and be able to figure out what base they're looking for. So 27 and 81, students will try to default to go to the smallest base, but 27 squared is going to be a number way bigger than 81. So what you have to think of is you have to think of a number smaller than 27 and 81 that would give you these answers. What it would actually be, it's going to be base of 3. You just have to recognize that these can both go down to base 3. Because remember, 3 to the power of 0 is 1. 3 to the power of 1 is 3. 3 squared is 9. 3 to the power of 3 is 27. And 3 to the power of 4 is 81. So we have to convert both of these to base 3. 27, rewritten in base 3, is 3 to the power of 3. And then we're going to put that x minus 2 outside the bracket. And you're going to put that in its own bracket because it is more than one term. This is equal to 1 over. Okay, we need to take 81 and we need to rewrite that in base 3. 81 is equivalent to 3 to the power of 4. Outside of the bracket, I have x plus 3, and that must go in its own bracket. Now I'm in base 3, and I need to do exponent laws here to get rid of these brackets. So this is power to a power, so we are going to distribute. That would give us 3 to the power of 3x minus 6 is equal to 1 over, what would this be? Sorry, same thing. Power to a power, 3 to the power of 4x plus 12. Okay, now this is 3, and this is really 1/3. So what we want to do is we want to bring this 3 up here. Now we reviewed from lesson 1. If I give you 1 over a, let's say to the 4, if you bring that up, that becomes a to the negative 4. So when we bring this base 3 up, we have to put a negative in front of this exponent. So what this is going to look like is my left-hand side is good, 3x minus 6. My right-hand side, I'm going to write this base 3 up top. I must put a negative in front of this exponent. Because it's more than one term, that the exponent is going in a bracket. Okay? Because when this gets written up here, the exponent must become negative. You're then going to get rid of that negative 1 by distributing it inside. 3 to the power of 3x minus 6 is equal to 3 to the power of negative 4x minus 12. We now have the same basis. So from there, we could drop the bases, equate the exponents. So dropping my bases, I would get 3x minus 6 is equal to negative 4x minus 12. Let's join our like terms. I'm going to bring this negative 4x to the left, which will give me 7x's. I'm going to bring the negative 6 to the right-hand side. And I'm going to divide both sides by 7 to get a final answer of x is equal to negative 6 over 7. So in order to do these questions, you just have to completely know all of your exponent laws, how to change bases, and then just be very procedural with your work. Students who are very procedural do very well in this. Students who are not very procedural do not do well with exponent laws. Okay, a good trick with fractions is if this is 6 over 5 or 6 and a 5, we basically want this guy to be a 6 and a 5. Okay, so I'll show you that's the first thing. Now you might say to yourself, okay, there's no exponent that I could raise 6 to that would give me 125, right? So if I went to my calculator and in y1, if I put 6 here and I look at my table, there is no 125, but there is a 216. So what that means is that I could raise 6 to a power to get 216, and I could raise 5 to a power to get 125. So I'm going to actually have to flip this, okay? So what I'm going to do is I'm going to write this left hand exactly as is for now. 125 over 216 to the negative 1 x over 4 is equal to, let's flip this to become 5 over 6. If you flip this, remember that if we flip a fraction, the exponent becomes negative. So I have to put a negative in front of this bracket. Okay, from here, I have 125 over 216, negative 1x over 4 is equal to 5 over 6. If I distribute that negative 1, I get negative 3x plus 3. Now I could rewrite this 125 over 216 to be a base of 5 over 6. So 5 over 6 to what 5 to what power will give you 125, and 6 to what power will give you 216. And that answer is 3. 5 to the power of 3 gives you 125. 6 to the power of 3 gives you 216. So what I've done is reduce this to base 5 over 6, because that's 5 over 6 to the power of 3 will give you 125 over 216. Outside of my bracket, I still have this negative 1x over 4, and this is equal to the right-hand side, which is 5 over 6, negative 3x plus 3. I've got the exact same bases, and I could now drop my bases and equate the exponents. Before I drop the bases, though, I really should do this exponent law over here, which is power to a power and multiply. So 5 over 6 to the negative 3x over 4 is equal to 5 over 6 to the negative 3x plus 3. Let's drop our bases. Negative 3x over 4 is equal to negative 3x plus 3. I need to get rid of, so I need to isolate this x. It's x divided by 4. The opposite of dividing by 4 is multiplying both sides by 4. 4 over 4 cancel, and I would get negative 3x is equal to negative 12x plus 12. We need to get rid of this negative 3x. It's x times negative 3. Divide this by negative 3. What you do to one side, you do to each term on the other side. And you would get x is equal to 3x. Nope, 4x, sorry. Just let me see where I went wrong for 1 second. Sorry, the mistake should be when I divide each side by, when I divide everything by negative 3, negative 12 divided by negative 3, this should be a 4x. And I'm going to erase this as well. Okay, so I should have, let's see if we do this right. 4, whoops. Okay, so negative 12x divided by negative 3 is 4x. 12 divided by negative 3 is minus 4. Then we've got an x on both sides of the equation. So we want our x's together and on one side. So let's subtract 4x here, subtract 4x here, and I get negative 3x is equal to negative 4. Divide both sides by negative 3, and I would get x is equal to 4/3. And that would be my final answer for that question. Okay, one thing that I want to mention. So this is a heavier lesson, especially this last class example is the most complex. You could start these questions, but there's 3 podcasts that you need to watch. So part B is a 9-minute podcast, part C is a 12-minute podcast, and then the diploma question. You could start these homework questions. I would probably do the podcast first, and then it will just reinforce some of these concepts. You'll see some of the same questions again, and then attempt the homework. Or you could do the homework until you get stuck and then go to the podcast. It's up to you to how you want to complete this.